his postdoc in his lab. My doctor major was mathematics, so today I'm going to fill in the mathematics part for this course for you. 所以因为我刚好专长是数学，那我这刚好就是用这一次的课来讲解。它有反应的，我现在麦克风不够长，我就用这次的课来教你们这个应用控制里面需要用到数学的部分。然后第一节课呢，会先做一个课程的介绍。For this first hour, I will give an introduction on the course. Any questions so far? Okay, so Professor Zhong is an expert in control and system identification. And you will see from this course some real examples and some theoretical methods. Okay, to begin the introduction for control theory, we know that it's an interdisciplinary subject between engineering and science. In this first bubble, you will see theoretical modeling. So it requires theoretical knowledge on physical behavior, such as we know the equations of motion from Newton's law, or using Hooke's law, we have the motions for spring mass system. The second component of control is experimental measurement. 点一下。好，刚才讲的就是理论的环节，然后接下来就是实物的测量。So to control something, we need an object to control, and we need experimental or actual data to work with. This small picture is a mass spring dashpot system that you often see in control. And what do we need to measure experimental data? This is a question for you. 所以我现在就说，假如我们要量测实验的数据的话，需要的是什么？ Anyone? It's like 什么？你吧？就是我们做控制呢，有理论的环节，然后呢也有实物的量测的部分。那我们大家都知道，实物量测需要什么？ 仪器，还有没有更精准的说法 you need instruments. Anything more precise than that you can say about data measurement? We need sensors, right? So, can you give me some examples of sensors? We will go through maybe 5 people from here. Everyone will have a chance to answer questions. So give me an example of a sensor and tell me what it's used to sense.
Sonar. Use sonar to measure the voice.
Sonar. 声呐是不是？好 ，Next one. Sensor 是中文是什么？感测器。还有什么？我要帮你说啊，你讲，然后我讲，帮你扩音。你呢？你？
哦，那个 Hall sensor。
哈
？Current sensor。
哦，就是量电流的 current sensor，OK？ Volt sensor or current sensor. How about you? 光学 optical blah blah. Decoder. Optical decoder. Okay, and the last one?
IMU.
IMU. What does that stand for?
Force sensor. It's a 测量角度的。
Okay, for angle, to detect angles. Do you have any? Temperature, for example, thermometers. There are many common sensors we use, accelerometers, or even the camera can be considered as a sensor. As long as it can transfer physical data into signal, then it becomes signal we can process with either a computer or instrument. We call that sensor. So when we have experimental data and sensors, what is the main issue? There will be measurement error, right? So this is an important part of controlling. We have to take care of the measurement error in the data analysis. So this, I know the right-hand picture is something like a microphone, but I'm not sure what this is. It looks like a lens or camera lens. And there's the third bubble I haven't talked about. Can we go back? And this third bubble, or the third component of control, is numerical analysis. Why do we need numerical analysis? Numerical analysis is what? What's numerical analysis? 就是数值方法嘛。There are several reasons why we need numerical analysis. First, if we have a theoretical model and we want to predict our, say, measurements or predict our motion from the equations, we need some way of simulating the behavior of this equation. So for many equations, well, for these two equations that you see up in the theoretical bubble, they have exact solutions. Exact solutions means that you have solutions that are good and pretty formulas. But for many more cases, we have no analytical method to write down a solve for a solution. In that case, we will need numerical analysis. So that's one of the reasons why numerical analysis is an important part. And the other reason is when we have experimental data and we want to process the experimental data, we come up with some identified model, and we also need numerical methods to process the identified data.